When you implement Quicksort, there are a ton of different choices you have to make. And those choices really matter. So those choices can affect the constant factors of the runtime of our algorithm, like it'll run twice as fast or whatever, depending on little tweaks you make. But the more important choices actually affect the order of growth. So if you make bad choices, then you end up having an algorithm which runs in n squared time when it should not. But those choices that you make can also affect the constant factors. So in this video, we're going to focus on the order of growth, and in the next lecture, we're going to kick off the lecture video with discussion of constant factors. So what are the choices you have to make? Well, one of them is how you select your pivot. Another is the algorithm you use to partition. And then lastly, there are a bunch of other little optimizations you can do. For example, switching to insertion sort when you only have 7 or 8 items left in a subproblem. So let's talk about that n squared case. That's going to be our focus for this video. And what I'm going to note is that if the pivot always lands somewhere good, we had a couple different ideas of what that means. Directly in the middle or in the middle 99% or whatever else. If the pivot always lands somewhere that seems reasonable, then Quicksort's going to be theta n log n. That was the analysis we did before. However, we do actually need to worry about that theta n squared, because even though it's very rare, and even though if you generate a random array it's just not going to happen, there are situations, like for example, if you give me an array that's already in sorted order, Quicksort will be really slow. Or if you give me an array that's almost sorted order, it's going to be really slow. Or if we have an array which has, for example, almost all duplicates, the Quicksort that we described will also be theta n squared. So we want to be worried about this, and we want to make sure that we're taking care of it. So what can we do? That's what you're going to be thinking about here. This blue slide, the question is, what do we do to make our Quicksort robust against these sort of situations? Now remember, our Quicksort had a couple of properties. One is that we always use the leftmost item as the pivot, and another is that our algorithm had always preserved the relative order of items that were less than or equal to, and those that were greater than or equal to. So we had 3, 1, 2, 4 as the red items before we did partitioning, and they're still in the same relative order. So just be aware that those are things that you could change, but you can address this in any way you want. And so think about it, and in the next video, I'll give you my answer.